everyone. Welcome. We can wait a few more minutes and start. All right. I think we have enough people and we can get started. I will continue admitting people from the waiting room as they roll in. I'm already seeing some notes in the chat, which is great. Everyone's saying hello to each other. We also have a poll that asks about your authorization journey. So if you see that, feel free to answer. It's optional. We just want to see where you are at your authorization journey. I'm going to share my screen. And let me know if you can see it. Cool. Awesome. Welcome everyone again. We're here to talk about how Google handles authorization at scale. And I'm here with Greg, my teammate from Developer Advocacy. And we are gonna discuss whether Google's approach is the best approach to secure your application permissions. Our agenda for today is going to be the Zanzibar paper. So we're going to discuss a little bit about the paper and its authorization implementation, and we will have a demo portion right after that. And then we will talk about the trade-offs and how also approaches authorization. And another demo will follow this up, and we will finish up with a Q&A session. Please feel free to ask any questions in the chat at any time. We will have our teammates monitoring it at all times. So what is authorization? Authorization controls what users can do in an application. And this could be like who can view a document, who can edit, who can delete it. And like, obviously, these could be any type of files. And you can think of Google Docs as an example. We all use Google Docs. You know how to give people edit access, comment access, view access. And this is between millions of users, obviously, and like a lot of relationships between teams, projects, and these all impact who can see and edit what. And this sounds simple, but this gets tricky at scale. And why is it hard? And why does it get like tricky as the companies grow? So updates like role or like the changes that you give to that specific role needs to happen instantly. So any delay can expose sensitive data or hurt the user experience. For example, if a user is removed from project, like if Greg is not in this project anymore, then they should lose access right away. Maintaining this consistency, especially across distributed systems, get very difficult and typically require a lot of engineering efforts. And obviously this has to function in like very huge scales, and this needs to perform consistently at high speeds regardless of the load. You will not be doing permissions on a day-to-day basis for just one person. You will need reliable access checks for millions of Gregs and millions of resources, which is why systems like Google Zanzibar were built to handle it. And you may ask, like, why should you care about all of this? If you're working with software that involves access control, whether it's managing permissions or protecting data, things can get complicated as systems grow. And like poorly handled permissions can slow things down, create security gaps, and frustrate users. So learning about Zanzibar and its implementations and trade-offs will help you understand the gold standards in authorization, and you can apply these to your applications, of course. And let's dive into the paper. Zanzibar paper is from 2019 and explains the design, implementation, and deployment of Zanzibar, which is a global system Google uses in-house for storing and evaluating access control lists. And Zanzibar handles billions of users and trillions of access checks efficiently, keeping ticks fast and scalable across all Google services. And obviously, Google Docs is an example of that. It uses a relationship-based model, ReBAC. Maybe you heard about this if you're higher in your authorization journey. This is where permissions are based on the relationships between users, resources, and groups. So since it relies on these fixed relationships to determine access, making changes to these permissions can get complicated sometimes and isn't as flexible when you need to adapt to dynamic changing needs. And to keep everything consistent and up to date, Zanzibar uses caching and data replication, so users can see the changes in real time with high availability and low latency. They centralize all of their data for this. And Greg, do you want to talk about the core two elements of authorization?
Yes. So I just, by way of brief background, I used to be a chemistry major, and I can't resist a bad joke on the slide. So the two core elements of Zanzibar, it also is really handy that you could spell auth with actual element names, are its implementation and its scale. Those are the things that the paper goes into. I can't recommend strongly enough actually reading the paper. It really is sort of the foundational text of the whole authorization as a service movement. But in this talk, we're going to focus primarily on the implementation, because I think that's what's relevant to most folks who are looking to implement a service like Zanzibar. So the three core pieces of that implementation are the data model, the configuration language, and the API. And we're going to go into the specifics of each of those over the course of this talk. So let's start off with the data model. And Hazal, I will hand it back to you.
Yeah, for sure. So Zanzibar's data model is called relation tuples. And let's see an example of what this looks like in practice. It consists of an object, a relation, and a user, and then it is formatted as what you see in the slide. For example, you could say that Greg is an owner of this file with a relationship tuple like this. Obviously, object is a file, relationship is being an owner of something, and then user is Greg. And let's get into more detail about how these are structured. So the object is expressed as a namespace. This is similar to a type, and an object ID. So something like document 123 or folder ABC would be an example of that. And the user can be either an individual, which is represented by the user ID, or it can be a user set, which is a group of users. So something like Greg would be an example, or all also employees would be an example of that. And the user set is expressed as an object and a relation. So something like reader on document 123 or admin on organization Acme would be an example of this. That is a set of all users who have this specified relation to the given object. So multiple people can be admins of the same organization. This gives Google a very prescriptive way to define authorization data. But what happens when your authorization data doesn't actually look like a relationship tuple? Greg, do you want to walk us through a scenario of how that would be?
Sure. So, there's a lot of syntax on these slides. It's sort of necessary to kind of dig into these formats. So I'd like to make this a little bit more concrete in the context of an application. So sort of throughout this talk and in the demos that follow, we'll use a scenario based around a task management application. This application has, oh, can we go back? Sorry, I was a little slow catching my breath. The model for this application is that you have users you can see in the top right that belong to organizations. And then you have tasks that are associated with projects, which also belong to organizations. And so, this is a pretty standard sort of hierarchical kind of object model. And that set of relations sort of determines how someone can gain access to view a task. And so we'll get into that on the next slide. So the ways that someone can view a task are that they can be a member of the project that owns that task, or they could be a member of the organization that owns the project, that owns the task, and then that permission filters down. Or you can view a task on a project if that project is public. So that means that we need to communicate some data to Zanzibar in order to allow it to determine whether someone can view a given task, right? So the sorts of things that we need to be able to express as relation tuples are which users are members of which orgs, which projects belong to which orgs, which tasks belong to which projects, and then finally, which projects are public. So let's dig into a little bit of how that looks. If we wanted to tell Zanzibar that a user belongs to the organization that owns the project, there are two things we can tell it. We need to tell it first which users belong to which organizations, and that is pretty much what the relation tuple was built to express. So if you look at the little tuple below the org user membership, we could tell Zanzibar that the user Alice is the member of the organization Acme, or strictly speaking, the user ID Alice has the member relation on the Acme organization. Then we just need to tell Zanzibar that a given project is also associated with that organization. And we run into a little bit of a wrinkle here. You'll notice some funky syntax at the bottom there. So we say that project 123, and then there's this trailing pound ... has the parent relation with organization Acme. That ... is a little bit of interesting syntax that comes in the paper. What's going on there is that if you recall from the description, if we move on to the next slide, the relation tuple was specified to define relations between objects and users. And so there are two things that you can do to specify which user has a relation with an object. You can specify a user ID directly, or you can specify an object and relation pairing. So in the bottom example there, you see that anyone who is a member of project 123 that resolves to a set of users has the parent relation on org Acme. But really all you want to do is say that project 123 has that parent relation with organization Acme. And so to get around that constraint, the Zanzibar paper introduces this notation where rather than specifying a real relation, you just put this ellipsis at the end of the object relation specification. And that tells Zanzibar that what you're expressing here is a relation between two objects and not a relation between a set of users and an object. So just a little syntactic wrinkle that's worth understanding when you're thinking about how to express an object-object relation given this syntax. When you want to associate projects with tasks, it's basically the same thing as a project and an organization. It's just you're assigning a project to a task. So we say project 123 is the parent of task 001. And then the next sort of big thing that we have to do is tell Zanzibar whether a project is public.
And now we come to the public project. So how can you express that a project is public as a relationship tuple? You can't just say that the project is public because that is not really a relationship. And it has to be written in terms of some kind of relation with a set of users or another object. And because you can't say everyone should be able to access this doc explicitly, you have to say every user has a read relation to this public document, which you wouldn't want to say unless there are any other options. And in our task management app, when a project is public, it means that all users are viewers on that project. So we can support public projects by writing a relationship tuple that gives all of the users, as you can see here, the viewer relation on any of the public projects. And one way that people find like a way to work around that is to create a global entity that represents all of the users. So instead of giving each person that permission, you can give the global user that permission. Then the members of that entity can be granted the appropriate relation to all of the public projects. And for example, like here, the tuple says that every user that has the member relation on the global all users object gets the viewer relation on the project 234. Now, as long as we add all of the new users to this global all user bucket, we effectively made the project 234 public, but like the all users can only view its issues as long as we keep adding them to this group. Let's talk a little bit about the configuration language as well. So data formats here are interesting, but if that was the whole story, then we would be talking about databases and not really authorization systems. So the thing that distinguishes an authorization service from a database is the ability to infer data from other data. And authorization services do this by means of logic, which is expressed in the configuration language. And I think it's worth looking at the Zanzibar's configuration language a little bit in a code sample.
Yeah, so I'll jump into that. So the Zanzibar configuration language, it's called referred to as namespace configurations in the white paper. This is what it looks like, and what it does is it tells Zanzibar how to infer or derive relations from other relations that are already defined in the namespace. So you can see here, you can have a project namespace, which defines the relations that exist for a project. And maybe we have, the notion of an owner of a project, and users can be directly granted an owner relation. And then you can have a more complex relation, which you see in the viewer below. And the viewer relation is defined by all of the users that are directly granted the viewer relation. And then this little syntax at the bottom here says, it also includes any user that has the owner relation, right? So this is the sort of notation, the way that you tell Zanzibar how to inherit one relation from another. The thing that's important to take away from this is that this is what the entirety of sort of what you configure in Zanzibar is relations on objects. So the configuration language, just as the data format is structured in order to represent relations, the configuration language expresses logic that derives relations from one another. So again, we're very focused on relationship-based access control. And then by combining our logic or our configuration language and our data, we are able to arrive at an authorization decision. And the way that that looks, as you might imagine in Zanzibar, is an API call that allows you to figure out whether a given user has a given relation on an object. And so again, strictly speaking, so Zanzibar's core authorization API is called the check API. And you basically pass the check API a user ID and a user set, which again is this pairing of an object and a relation. And then it tells you whether or not that user belongs to the user set. So you ask Zanzibar, does Alice have the view relation on project 123? And it tells you yes or no. So again, the API here is also geared towards letting you know whether a user has a relation on an object. And that's sort of how you resolve authorization decisions using the Zanzibar check API.
And I guess let's just like look in the context of the application request and like give an example. Imagine Alice, which is our person, wants to view the employee handbook, and you want to authorize that request with Zanzibar, and you don't know yet if they can do that. You use the check API to ask Zanzibar whether Alice has the viewer relation. And note that the question you will ask Alice, ask Zanzibar about Alice would be, does Alice have the viewer relation on the handbook document? And this is related to the question you're trying to answer internally, does Alice have permission to view the handbook document? But it's not the same question, and this will become important as we go along with the slides. Zanzibar says yes, Alice has this relation to this handbook, and you know that Alice can view the document after that. And this works perfectly fine when there is a one-to-one mapping from relation to action. So view and viewer or write and writer, it's easy to infer that required relation from the requested action in that case. Now, suppose you have an owner relation and owners get many permissions at the same time. So you can delete something, you can move, you can transfer ownership. How do you handle this type of scenario in Zanzibar? It starts the same. So you have the same person, Alice, and they make a request to delete the handbook, and you need to authorize that request. And since owner have the permission to delete documents, the question you ask Zanzibar is whether Alice has the owner relation on the handbook. But hold on, like there is a problem there. Greg, do you want to tell us what it is?
Yes, yeah. So there's a hitch here, which is that Zanzibar doesn't distinguish between relations and permissions. So there's not a sort of built-in notion of a relation that grants multiple permissions on an object. So if you've defined the namespace the way we did sort of in the sample here, where you have an owner relation and a viewer relation, Zanzibar can tell you whether a given user is an owner or a viewer, but it doesn't have any way of knowing that owners are the people who can delete, or owners have the permission to move an object. So there are a couple of ways that you could tackle this. One naive way would be to just put a function in your application that says, okay, well, let me map actions that are going to come in to the relation that has permission to do that action, so that I know which relation to ask Zanzibar for when it comes in. So you could have a silly little function here where I say, if someone asks to delete, what's the relation that has that permission? And then that function tells you it's the owner. This is a little bit, as I said, naive. It's not really something that you would want to do, because you've gone to the trouble, right, of implementing an authorization solution, but here you're basically building authorization logic into your application to make that mapping from requested action to permitted role. So instead, what most folks do who implement Zanzibar style ReBAC solutions is you just treat the permissions as though they're relations, right? So Zanzibar does allow you to build up relations from other relations. So if we create relations that correspond to the things that users are going to ask to do in our application, then we can map other relations onto those permissions and do the inheritance that way. So this is something you see actually fairly frequently in ReBAC documentation and in the space out there is modeling permissions as though they were relations to deal with this sort of thing. And so you see here now we've changed our viewer relation to a can delete relation, and the owner relation is granted that can delete. And so this is a way that we can kind of go back to that one-to-one mapping from the action that is requested to the relation that is allowed to do that. But by adding the owner relation to all of the different actions that could come in, we can model this sort of one-to-many relation to permission sort of scenario that you see pretty commonly in applications. So what this does is it sort of has the effect of recasting, right, that permission question in terms of a relation question. So now, rather than having to put some logic in our application to figure out, does Alice have the owner relation on the handbook document, we just ask Zanzibar, does Alice have the can delete relation on the handbook document? And under the hood, because Alice has the owner relation, Alice will inherit that can delete permission. So it just allows us to sort of reframe our permission question as a relation question.
Mm-hmm. And let's see what this looks like in practice. So I'm gonna stop screen sharing so you can share a screen, Greg.
All right, so the ever popular screen share handoff. Bear with me. I'm notoriously bad at this, so hopefully you'll actually see the screen that I intend to show. It looks like it. Okay, yeah. So we're gonna take a look at this in terms of that task application that we were talking about before. So just to sort of reorient there, imagine we have a task management application where users gain the ability to view a task by virtue of being a member of the organization that the task is associated with, right? So fairly standard kind of relational model. what we have backing this is a relational database that that has a couple of tables. There's a task table with your usual columns, and the one that's really relevant to authorization is tasks are associated with a project ID, right? And that's how this is how we represent this in a relational database. I should say, Sean has actually already alluded to this once in the chat, but because Zanzibar is not actually a publicly available technology, we don't have Zanzibar to operate with. So this is going to be a bit more of an illustration than an actual demonstration, but I'll walk through kind of how this would look under the hood with Zanzibar, even though I can't call Zanzibar. Mm-hmm. So this is what a task table would look like. And then we have another table that associates the projects with their organizations and tells whether a project is public or not. So this gives us the data that we need to get over to Zanzibar. One other bit of data is mapping users to orgs. And so we mentioned Zanzibar is not operating over your relational database. It works with tuples. So something that's pretty common when adopting solutions like this is to do kind of a load of the data that drives your authorization decisions into that application. So you might generate a bunch of org tuples or a bunch of relation tuples from the data that exists in your relational database, and that would look kind of like this. So if I want to map users to their orgs for Zanzibar, bear with the UUIDs here, but this is what this looks like, right? So I have a user ID here that is granted the member relation on an organization here, right? And so you see we have a whole bunch of these, and this is just the way we can tell Zanzibar with relation tuples, this is how all of the users are associated with organizations. Then we can do the same thing to associate projects with their parent orgs, right? So you have this organization using that dot 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 notation to let Zanzibar know that we're doing an object-object relation here is the organization that contains this project. And now we tell Zanzibar how projects are related to orgs. We do something similar for projects and tasks. So this is the project that is the owning project of this task. And then finally, we need to let Zanzibar know which projects are public. And the way that we do that, as Hazal mentioned with relation tuples, is we have to do two things. We have to tell Zanzibar that we have to give it some collection of all of our users. And then for any project that is public, we have to grant all of those users the viewer relation on that project. And that's how we tell Zanzibar that a given project is public, by letting it know that all users have the view relation. And so we create this sort of global all users entity, which is just a catch-all entity to represent all of our users. And anytime we add a user to our application, we associate that user ID with the member relation on that entity. And then once we've got that built up, now all we have to do is for any public project, we take the project and we associate all of the members of that global all users group with the viewer relation on that project. And so this has the effect of letting all users view any task that belongs to these projects. So now we've given Zanzibar all of the data that it needs. Now we just need to express the logic, and I'll try to go through this pretty quickly. But the logic is expressed in these namespace configurations, as we mentioned. And so we just have to tell Zanzibar what relations are available on which of our different objects, and then how a user can be granted the viewer relation on a project in order to see tasks. So the first one is an organization, and it's pretty simple that you can be a member of an org, and that's it. And so this is how we tell Zanzibar that there exists a thing called an organization, and you're allowed to be a member on it. Then we can associate projects with organizations by defining a project namespace. And again, there's just the one relation. You can be a viewer of a project, but now you have two ways of becoming a viewer. You can either be directly assigned that viewer relation, which is this notation here, or you can be assigned the member relation on the organization that contains that project. And that's what this little bit of syntax is here. So this is how we tell Zanzibar that members of an organization inherit the viewer relation on any projects that belong to that organization. Then we do something similar to associate tasks with their parent organization. The one wrinkle here is that we also defined an owner, which we're just going to do to illustrate that multiple permission thing a little bit later on. So you can now see there are three ways to become a viewer of a task. You can either be directly granted that viewer relation. You could be an owner, and that way you inherit the viewer relation on a task, or you can be a viewer on the project that owns the task. And so that's how we sort of build up this hierarchy from organization to task. And then finally, we just define this global namespace. And that global namespace, again, it just has a member relation, and this only exists so that every time we add a user, we can grant that user the member relation on our global all users thing, so that we can grant that global all users entity read the viewer permission on a project. And then that allows them to inherit the view relation on tasks. So when we come back to this for OSO, we'll be able to see sort of functionally how these sorts of notions affect the application behavior. But for now, for Zanzibar, we'll leave it in the abstract.
Cool. Thank you so much. I will continue sharing my screen. Let me know if you can see it.
Yeah, I can see it.
Okay, great. This was just like an illustrative version of Zanzibar. As we said, Zanzibar is not publicly available, so we can't actually run the code, but I hope we gave you some insight on how this looks like in technical terms. And I think now it's time to start comparing it with also, because we are not Google. We made a bunch of different design and architectural decisions, and we want to talk briefly about that. The recurring theme of the Zanzibar approach to authorization is that it's prescriptive. And we talked a little bit about this. The data format, the logic language, and the API are all tightly specified in order to define authorization in terms of relations between objects and the users. As you saw, all of the permissions are expressed in a way that you have a relationship to an object. And this approach makes a lot of sense at Google, which has a famously monolithic culture and the ability to enforce top-down standards. But when we set out to make OSO Cloud, we learned that this prescriptive approach caused some friction in a more general purpose solution. Greg, if you want to walk us through an implementation of that.
Yes, yeah. So anytime we felt or we heard from our users that sort of the more prescriptive approach was generating some friction in their authorization implementation, we chose to move sort of in the direction of flexibility versus the prescriptive approach. Both of these approaches work just fine for authorization. We've just found that by relaxing some of the constraints in the more rigidly defined ReBAC model, we're able to sort of model more application authorization notions that we encounter out in the wild in OSO Cloud. So the distinctions come in those three areas that we talked about earlier: the data model, the configuration language, and the API. So we'll get into each of these now in the subsequent slides, and we'll do the same order. So where the Zanzibar data model is relation tuples, which are both a very highly structured and a very prescriptive data format. In OSO Cloud, we model data in terms of facts, and facts preserve the structure. It's still a very structured data format, but they relax that prescriptive nature of relation tuples and are built to allow you to express things other than relations as data in OSO. So if we want to go back to the sorts of data that we wanted to capture for our task app, to represent these various things as facts, you would write them as you see here, right? So we usually think, when we're talking about relations between users and objects, we usually think in terms of roles. And so you could have a fact that says has role to assign a given user a specific role on a given organization, right? So this is how you would say that Alice is a member of the Acme organization. Then you can have facts that associate one project with another or one object with another. And again, using just a sort of consistent object syntax. So we can say here that the organization Acme has the parent relation with project 123 with a fact that looks like that. Similarly with tasks, right? So you just define the two objects and the relation that they have. And then really the big sort of distinction comes when we're talking about things like pure attributes, like whether a project is public or that sort of thing. And for that, we just can express that directly in terms of a fact. We can say project 234 is public with a fact called is public. to which you assign a project. So this will have some implications on how then authorization is modeled in particular for public projects. But hopefully that sort of makes the distinction clear between how you express things in one syntax and versus how you express them in the other. So why don't we take a little bit of a look now at the configuration language, and Hazal, I'll turn that
Yeah.
over to you.
So when we build also Cloud, we obviously wanted developers to be able to build their authorization model around their application instead. So we created a logic programming language called Polar. If you see our logo, it's like a polar bear as well. So that loops back into that. But this is a declarative language for modeling and enforcing authorization policies. And it allows developers to define who can perform which actions on which resources by writing simple human readable rules. As Greg mentioned, when you see is public, that actually means something is public. So it's very easy to understand as a developer, like what each of those facts mean. And Polar supports patterns like role-based, relationship-based, and attribute-based access control. So it does a little bit more than just relationship-based. And this enables obviously scalable authorization systems without having to write custom code for each and every authorization check. And let's consider how we define the owner relation and how this could grant multiple permissions in Polar. So first, we should note that the permissions are distinguished from roles. As you can see up top here, the permissions could be view, write, delete, move, transfer, and like many more. And then the roles could be viewer, writer, owner, admin, like any of the roles that you would have in that specific document. This allows you to then assign multiple permissions to a role. And this works closely with like the mental model of people like when they're thinking about authorization. So you can have the delete permission if you're an owner, you can have move permission if you're an owner, you can have transfer permission if you're an owner, and you have some role on this resource, and like that role grants you all of these permissions. And we should also take a look at how we handle public projects in Polar, because this contrasts with what we showed earlier. In this example, we grant any member the view permission on a project if the project is public, because also can represent whether or not a project is public as a fact. We can write logic that accounts for public projects directly. So you don't have to individually add every single person as a relationship to this public document. You don't have to rework that logic in like different terms because we have Polar.
Yep. So let's now take a look at the API. So you'll remember, I think, from the discussion of Zanzibar that because Zanzibar is oriented towards a relationship-based access control implementation, the semantics are all built around relations, and so the check API in Zanzibar is built to allow you to determine whether a given user has a relation on a given object, because that's how the authorization implementation works. In OSO, the key authorization API is the authorize API, and it's written in terms of permissions. It's you're asking basically, does a given actor or user have permission to perform a specified action on a given resource, right? So again, just a different way of framing the question that's driven by sort of the implementations of the different solutions. So this is sort of an outgrowth of the fact that we've built OSO Cloud around the notions of permissions rather than the notion of relations. And relations are one way among many that can grant someone a permission on a given object. Again, this is all sort of abstract on slides, so we're gonna try to take this back into an application to make it a little bit more concrete. And I will do the screen share handoff again briefly to pick that up. All right. I don't want to jinx myself. I got it right.
Greg, I just saw your joke. ReBAC beer-based access control.
I couldn't let it go. I think I mentioned earlier I cannot resist a bad joke. Okay, so coming back to our application, let's again take a look at the application itself. So just to to reorient, we have this task application where users gain permission to view tasks based on their membership in an organization that is associated with the task. If you look at this, you don't actually have to look too closely. You'll notice that right now we're showing a bunch of tasks that, strictly speaking, Jamie, who is a member of the Kuhn Klucko organization, shouldn't be able to see. Right? Here's a task that belongs to an unauthorized project, but it's showing up here. And any of these tasks that show unauthorized are tasks that Jamie shouldn't be able to see, but is right now because we haven't hooked in the authorization mechanism. So just as we sort of walked through how authorization was implemented in Zanzibar, we'll do that overview for how we do it with OSO Cloud, and then I'll actually hook it in so you can see the implication for the application, since I do have access to OSO Cloud. I hope. Hopefully it hasn't been revoked during the course of this webinar. So whereas data is represented as relation tuples in Zanzibar, in OSO Cloud, we represent it as facts. And we'll just go quickly through the same sorts of associations we made before. If I want to map users to their organizations, I define has role facts that say that this user has the member role on this organization. And that lets OSO know that that user is associated with the org. Then I need to associate projects with their parent organization, and they're scrolling off a little bit, but I can do that with some has relation facts that say, this project belongs to this organization. And so I just specify the different project IDs and organization IDs that are associated in that way. And then I need to associate tasks with their parent project, and it's the same sort of notation. Here's a has relation fact. Apologies for the horizontal scrolling, that associates this project with this task. And so now I've told OSO Cloud how organizations map to projects map to tasks. The one thing that we have left to express is whether or not a given project is public. And as we showed on the slide before, we just do that with a single fact. We tell for each public project, we provide a fact that says this project is public. Right? So this contrasts with the more relation-based approach, where we created a group of users who we could then assign the viewer relation on a project in the Zanzibar world. So with our data constructed this way, now our logic is expressed in a polar file. Again, rolling with the bear theme. That is able to operate over that logic. So where we had namespaces to define the relations that were available for a given entity in Zanzibar, we define resources that map to our application entities in polar files for OSO. And then those resources can contain the roles and permissions that are available and how one is inherited from another. So you'll see here, very similar to the organization namespace, we have an organization resource that defines a member role, and that's the only role there. And then we have a project resource that has a member role, and it has a view permission. So one thing that kind of jumps out here immediately is that there is a distinct notion of permission as separate from a role and as separate from a relation in Polar. And so we can specify those things individually. We can say that the project resource supports the member role. There is a view permission on a project resource, and we can say that projects have a relation with organizations. So we can still encode relations in Polar as well. And then once we've defined those roles and permissions and relations that are available, we can start writing rules that determine how roles are inherited and how permissions are granted. And so this rule right here just says that you are a member on a project if you're a member on the organization, right, that is related to that project, which we assigned in the facts. And so that's how we associate projects with orgs logically. And then we can start granting permissions. So you get the view permission on a project if you're a member of that project. And then here we can show that you get the view permission also if the project is public. And this actually is someplace where I do want to jump back briefly to the Zanzibar implementation, because I think one thing that actually wasn't even clear to me until like 2 hours ago this morning as I was going through this, is that if we look at the project namespace, although it's possible to model public projects in Zanzibar, given this sort of construction, it's not obvious from looking at the project namespace configuration that there is a notion of a public project in the authorization model, right? Like we have a mechanism that allows us to make a project public by granting all of our users this viewer relation. But if I look at this, nothing jumps out to me that says there is such a thing as a public project, and that by virtue of being public, someone will gain some kind of a permission on it. That all kind of gets implemented externally to the policy itself. Whereas here, one of the things that does immediately jump out is that we can see that there is some notion of a public project, and that notion has an implication. You gain a view permission. So again, they're two different approaches to solving the same problem, but there are implications for where logic lives and how how you can determine sort of what the actual workings of the authorization policy are, versus with one versus the other. So then finally, what we actually care about are tasks and whether or not someone can view a task. And so we do that by relating a task to a project, and then we say that you get the view permission on a task if you have the view permission on the project. And remember, you might get that view permission on the project either by directly having it assigned, or by virtue of the project being public, or by being a member of the organization. So this is how this all looks in Polar. If we just want to briefly look at the code that implements this authorization, I've kind of janked this up a little bit for purposes of a demo, but basically we have a little variable here that just turns authorization on and off, and that's the crux of this. So right now we're able to see all of our all of the tasks that exist, because I'm not actually authorizing anything. Let me see if I blow this up a little bit, maybe. But if I make this false, now I will start implementing this authorization filter. And what this does is it allows OSO to ask, or it lets us ask OSO whether a given user has the view permission on a given task, right? So that's what this OSO list local call is doing, is it's determining which users have the view permission on a given task. And if we make that change and then only return, you can see we're actually selecting only those tasks where the authorization filter is true. Once that happens, now you can see all of those unauthorized are now gone, and we're only seeing tasks that either are associated with the organization that Jamie belongs to, Kunkwako, or if they're in a different organization, they're public, and that's what this little globe shows here. The public tasks are visible to Jamie. And so that, I know kind of a 90-mile-an-hour version of going through this, but that is how we can sort of model authorization data and authorization logic, and then hook in just a quick question to OSO and say, does this user have permission to view this task, and start authorizing the results that come back. Okay.
Yeah, thank you so much for running us through the demo. I am going to continue sharing my screen. We have, I think, one more slide left. Cool. So if you only want to remember two things from this webinar, it's 54 slides, I think, and 2 demos. We want this to be the distinction between modeling approaches and the configuration language. So also uses Polar as we discussed, and we just shown an example. It's a declarative language that defines authorization rules and relies on facts rather than relation tuples to represent the authorization data, which gives it a little bit more of a semantic meaning. In contrast, Zanzibar uses a centralized relational model with a focus on managing permissions across large-scale environments. But as you saw, all of these relationships are between the objects and users, or between users and users, but everything is a relationship, in fact. Now we are ready for Q&A. We saw some questions on the chat already, but if you didn't ask your question, feel free to mute yourself or write in the chat and I can continue reading them. I'm also going to finish the poll. So if you saw at the beginning of the session, I made a poll about your authorization journey. Where do you feel you are in your authorization journey today? A lot of people said they are beginners or intermediates. Let me end the poll so I can share the results with everyone. This is very interesting to see. If you were a beginner or a newbie, do you feel like you learned some of the new concepts today, or you feel a little bit more qualified to talk about authorization? Or is there anything else you would like to learn to feel a little bit more confident when it comes to authorization knowledge? Please let us know. There's a question in the chat. Does also have a way to limit which attributes are available to view for a given entity? Greg, do you want
Yes, there is. So I'm like looking around to see if I could. So we refer to that as field level authorization, and yes, OSO does provide the ability to implement field level authorization. I can put a link to the docs behind it there, but essentially you can build sort of compound types of permissions, right? Where you have like entity.attribute that you then grant some sort of a permission on. So we can pull up those docs and show how that actually works under the hood, but the answer is yes.
Cool. We have another question. I have the following use case. A user can only access a document if the document is inside the folder of another user who's a subordinate. This means two users with the same role can end up being able to see different documents. How would you model this?
Trying to wrap my head around this. So a user can access a document if the document is inside the folder of another user who is a subordinate. Two users with the same role can end up being able to see different documents. Oh, so yes. So I guess we're not restricted to only implement. So I confess right off the bat, I would have to kind of go back and model this a little bit more in more depth. Although if there's someone on the line who is a better on the fly modeler than I, do feel free to jump in. But you don't have to just say, if you have this role, you have access to these documents. So we can specify that like this user can view this document if we can incorporate the relationship with the folder and the ownership on the folder into that decision, so that we can break down in a more granular way than just by role whether someone can view a specific resource. So again, I'm better at sitting down and writing these out than I am at answering them verbally on the fly in a chat. But
Greg, if I can offer something just real quick.
bail me out, Sean.
No, certainly, I'm certainly not bailing you out, but I think that you said the thing that I would say, which is just that kind of modeling that we offer is not only role based. So, two users can have different roles, but based off of their relationships with other resources, like other users, like maybe they're a manager or a subordinate or something like that. We can also model those using what we call ReBAC or relationship based access. So there's a lot of flexibility in the stuff that you can express. So actually, how would we model it? You'd model it through ReBAC, writing the actual modeling in Polar. To Greg's point, is not so easy to do just on the fly.
Awesome. Another question. Can you talk about how integration evolves as a project scales over time? What are best practices to maintain and backfill new system roles, scopes, entity types? How to keep a team of developers coordinated on authorization requirements?
Yeah, we've actually been talking about that a lot and learning a lot about that from customers. We actually are working on. We can drop a link to this doc in there. An integration guide that we're currently calling sort of the road to production. But the I guess the key elements are to one of the things that we encourage people to do is sort of start small and add complexity over time as you can do it, so that you're not, one of the things that can be overwhelming with any sort of sophisticated software system is trying to do everything all at once. And one of the real strengths of OSO is that you can build policies that are based on fairly simple constructs like roles and documents and simple relations to start, and then add in more complex relations or more complex logic over time to sort of modify that policy as you gain comfort with the implementation. And so what we generally encourage people to do is find some well understood domain of your application. Maybe it's like global roles for an organization or something like that, and build that into your authorization policy and get all the plumbing in place and wire things up and make sure that you're comfortable authorizing something with Polar and like deferring that decision to the application. And then once you've sort of built all of that initial groundwork, then it becomes fairly straightforward to say, oh, okay, now we want to add relations between organizations and projects, or we want to add relations between users and their teams and the projects that they're assigned to, or we want to start allowing like the support team to inherit permissions of users under specific circumstances. Like all of these things can be sort of added iteratively to the policy. And another sort of really important sort of integration feature that we provide is you can write policy tests that that allow you to confirm that given this set of facts, these people should have access to this permission and these people should not have access to that permission. And so as you're adding those things in, if you're writing tests to verify that the things that you've already built behave the way you want, those tests can keep running and catch anything that breaks as you start to enhance your policy. So that's at a high level, sort of generally kind of what we recommend. Like start small, start simple, write tests to confirm that the application and the authorization policy does what you expect, and then add complexity over time and just keep making sure that those tests continue to pass as you do so. And it sort of allows you to build things in more of a stepwise manner and with more confidence than just trying to do the whole thing all at once.
Cool. We have one last question that we did not answer. I want to be careful of the time. We have 2 minutes left. What if my company has its business roles taxonomy, capability taxonomy, asset taxonomy in a semantic store? Can also Polar pull in and reference them via URL instead of organization to say some URL organization dev?
Yes, yeah. So briefly, yes, yeah. The entities that we use here are just kind of by convention, and organization and project. These are things that are familiar to most. But one of the reasons that we sort of went with flexibility over sort of prescription when making some of these decisions is so that we could represent different sorts of data as needed. So you could have facts called anything you want. You can have entities called anything you want, and whatever you choose should be those things that map most closely to your application and make sense to your organization.
Cool. Thank you so much all for joining. We are going to share a recording of this webinar on YouTube. We will also share it on socials and follow up with all of you. I know Sean shared a bunch of documentation in the chat, so if you want to read the Zanzibar paper, it's there. We also sent a blog post that Greg wrote about all of this, and like it kind of distills the concepts that we talked about today. And we also shared a document about Polar and its conceptual overview. If you have any other questions, feel free to reach out to us. Also comment on the YouTube and we will continue answering. And we're just excited to see you in the next webinar.
Yeah, thank you all very much. It's been a great morning or afternoon.